Hi, I'm Andy Link. Welcome back. Let's take a look at some more of the topics that we will cover in Basic Petroleum Geology. One of the things that we'll do is take a look at different depositional environments, how sediments are laid down in under different conditions to give us different kinds of reservoirs, which is ultimately what we're interested in. So if we take a look at this diagram here, we have the sediment source. This is where the sand and the mud is made up here in the mountains. It's brought down, deposited on part of it is deposited on the alluvial fans, and then you can continue down the alluvial fan into the braid plain, and then the braid plain becomes the meander plain, and then we get down to the deltaic environment. So all of these are sites of deposition that are above sea level. One of the things that we'll take a look at is the distribution of velocity of water in fluvial channels. Fluvial is a general term for river. We have two kinds of rivers. We have the Braided River and we have the Meandering River. If you're not sure which one you have, you just say that you have a fluvial system, and so you know that it's a river system. And we can also take a look at the characteristics of braided and meandering rivers. Because of the two types of rivers that we just mentioned, we'll take a look at the differences between them. We'll take a look at some of the deposits related to both kinds of rivers. We'll take a look at channels, we'll take a look at point bars, we'll take a look at natural levees, and we'll take a look at Oxbow lakes. Then we'll take a look at the characteristics of floodplain sand bodies. The reason that we care is because these are some of the reservoirs that we are looking for. A river, whether it's braided or meandering, will move the material that it carries in three different ways. Some of it will be in solution, so that'll be the dissolved load up in the water column. Then we have the suspended load. This is the muddy water that you have sitting above the bottom of the river, and that material is small enough that it can be carried up in the water column and moved downstream. Then you have other materials which are too big to be carried up in suspension for any period of time. However, they're small enough that they can be rolled and bounced along the bottom or along the bed of the river. So we refer to that as the bed load of the river. It's also related, of course, to the total load that the river moves in the dissolved load and the suspended load as well. So if we take a look at a braided stream is going to be a series of essentially relatively straight, and I do mean relatively straight, but not perfectly straight, individual channels. And these channels will divide and rejoin numerous times along their lengths. And so if we take a look at a braided stream, this is from Iceland, and you can see that you're dealing with a whole series of individual channels that divide and rejoin along their lengths. The gray area that you see in here, that's some of the material that was carried and deposited by the Braided River. However, it is not yet covered by vegetation, most likely will not be covered by vegetation. But the average grain size for this particular river in this vicinity in here is going to be somewhere in the neighborhood the size of maybe a softball. So you're dealing with very, very large particles that are being carried by this braided river. If we consider what the architecture, if you will, of a braided river, we can see that we are dealing with lots of sand. That's the stuff that's in yellow right here. So we're dealing with lots of sand with the occasional fine-grained layer periodically throughout. As a result, we have a lot of potential reservoir in here. One other characteristic of the braided river is that the channels tend to be relatively wide and shallow, as opposed to the meandering ones, which we'll talk about in a minute. Petroleum production from braided rivers is, we find it, talk to the people up in Alaska. They'll say, yeah, we do get production from braided rivers. Best example of that is going to be Prudhoe Bay up in Alaska. This section of northern Alaska used to be at one time, used to be farther to the east in Canada. But because of plate tectonics, that segment of continental material was brought over to northern Alaska and attached itself to Alaska. So essentially, we took away from the Canadians and they gave us some of their oil. If we take a look at this illustration right here, we have a section, a vertical slice into the ground along the line end S right in here. And you can see that we have down here the Brooks Range. The Brooks Range was formed by the collision of that segment coming from Canada, swinging over and attaching itself to northern Alaska. And as a result, you created the mountains the same way that the Zagros Mountains are created by the Arabian Peninsula moving into southwestern Asia. We have in front of that, we have the Colville Trough, which is a very deep trough, about 28,000 feet deep. It's completely filled up all the way up to the top. And so that corresponds to the Arabian Gulf, that great big trench in front of the Zagros Mountains in Saudi Arabia. Then you come up on top of the Barrow Arch, which is right here along the coast up in here. And so what we have is the kitchen down here in the Colville Trough. That's where we generate the petroleum, and then it migrates up onto the Barrow Arch to the north, and then that's where we have it retained in the reservoirs. This is the depositional model for Prudhoe Bay. And so you had the mountains over here acting as the source for the sediments, and then you have the rivers coming out of the mountains over here, braided stream type deposits. You had fairly close to the mountain source over in here, larger grain size, and progressively finer and finer grain size as you go farther and farther downstream. Here we have an example of a meandering stream. The high velocity, high turbulence area is pretty much confined to the middle. And then as it continues to move off to the upper right, it encounters the cut bank. So our high velocity, high turbulence is being pushed over towards the edge of the river right in here, which means that you have erosion along the cut bank. If you have erosion on the cut bank, that means that the river is essentially getting wider, but we know that that can't happen because you'll get an energy drop if you do that. So as you cut and erode the bank over here, you deposit on the inside of the meander loop, you have a point bar, which is reservoir. So we have a point bar over here on this side of the river, the left-hand side of the river. For the next loop that you have downstream, it's now shifted over here to the right-hand side. And so this is reservoir here, this is reservoir here, and these are the kinds of things that we explore for. So if we start out with a relatively straight segment of river, we have the initiation, if you will, of a point bar over in here. Then this thing will continue to migrate. This curve will become more exaggerated over here towards the right-hand side. So that's what we see here in the second section right in here. Notice that our point bar is now quite a bit bigger than what we saw over in here. And so this is going to become something of interest to us in terms of petroleum potential. We have another point bar being created up in here, which is going to grow towards the lower left. And we have another point bar over here, which is going to be growing to the upper left. And so this whole curve situation becomes more exaggerated, such as you see over here on the far right. This point bar is now quite a bit bigger. This point bar is quite a bit bigger. This one is now almost completely surrounded by river. The next stage will be that we cut through right here and leave this whole thing behind along with that point bar. And so this is potential for petroleum, this is potential reservoir, this is potential for reservoir. Okay, here we have an Oxbow Lake on the Mississippi River. This is point bar inside here. This is reservoir. Notice that we have another Oxbow Lake over in here. There's point bar inside there. So we have two potential reservoirs. Come back in 50 million years when this is maybe 10,000 feet into the subsurface, we might have petroleum in both of these. So thank you very much for your attention. We will continue on to another topic.